Today we will discuss about inverse trigonometric function. Before starting inverse function, let me tell you about 1 and onto functions. A function f is such that a tends to b is said to be a 1 function if each and every element of a has a unique image in b, then it is called an 1 function. That is set A and set B. The elements of set A are these and the elements of set B are these. If I draw a function from A to B, the images of set A are in set B which are unique. It is called a 1 function. And what is many one function? A function f is such that A tends to B is said to be a many one function if there exists at least two elements in A which has a same image in B. It is called many one function. More than one elements of B has a same image in B. It is called a many one function. What is onto function? Onto function means when the entire B participates in range formation, that is each and every element of B has at least one image in A, it is called a onto function. If there exists a element in B which has no pre-image in A, that is the entire B does not participate in range formation, which is called a into function or not onto function. Now, these are the example of 1 and onto function. Function set A has 4 elements and set B has also 4 elements and their images are respectively this. This is example of 1 onto. This is example of many one and onto. Many one and onto function. Onto means when the entire set B participates in range formation, we call it a onto function. Let us move on to inverse function. In inverse function, there are 6 functions. Number 1, sin inverse of x. Number 2, cos inverse of x. Number 3, tan inverse of x. Number 4, cot inverse of x. Number 5, sec inverse of x. And number 6, cosec inverse of x. For sin x, let y equal to sin x be a function. If I draw its graph, then its graph is 0, at 0 it is 0, at pi by 2 it is 1, at minus pi by 2 it is minus 1, at pi it is again 0. This graph is a periodic graph. The graph of sin x is periodic, that is why it is a periodic function. All periodic functions are not 1. Why not 1? Because they repeat itself after a fixed interval. For sin x the period is twice pi. Now, we have to restrict its domain to make it 1. If I restrict the domain from minus pi by 2 to plus pi by 2, then it becomes a 1 function. For sin x, if I restrict the domain from minus pi by 2 to plus pi by 2, its range will be minus 1 to plus 1. Now, this function is a 1 function. To make it a 1-1 function, we have to restrict the domain of sin x. Now, if I define a second function sin inverse x, when I find a inverse function, what we do? We just switch the range and domain. Now, the range of sin x becomes its domain -1 to +1 tends to -π/2 to +π/2. This is called the inverse function of sin x. We call it sin inverse of x. Let us draw the graph of sin inverse of x. For -1, the value of sin inverse of x will be is equal to -π/2. It means the angle at which sin theta attains the value -1 is equal to -π/2. This point is -1, -π/2. Let this line is -π/2. This is +π/2. And for +1, the value is equal to π/2. If I join these coordinates, we will get a curve like this. This is the curve of sin inverse of x. Hence, we can write the domain of sin inverse of x is equal to -1, +1 and range is equal to -π/2, +π/2. This range is also called principal value. We call it principal value. Now, what is principal value? Principal value means the smallest possible interval in which a trigonometric function attains all its possible values. Now, in the interval -π/2 to +π/2, sin theta attains all the possible values. The maximum value of sin x is 1 and the minimum value is -1. In between the interval -π/2 to +π/2, sin theta attains all its possible values, minimum to maximum, its range. Hence, it is the principal value of sin inverse of x. Let us talk about cos inverse of x or cos x. At first, cos x. If I write y is equal to cos x, then if we draw its graph, the graph of cos x is like this. At 0 it is 1, at π/2 it is 0, at pi it is -1, this is -1 and this is +1. The graph of cos x is also periodic, that is, it is not 1-1, it is a many-one function. To make it a 1-1 function, we will restrict the domain of sin x from 0 to pi. This is 0. From 0 to pi, if I restrict the domain of cos x from 0 to pi, we get a function like this. Now, cos of x such that domain is 0, pi tends to -1 to +1, where -1 and +1 are the range of cos x. The maximum value of cos x is 1 and the minimum value is -1. At 0 it is 1, at pi it is -1. Now, if I find cos inverse of x, the range and domain of cos x will switch. Now, range of cos x is -1 to +1, it becomes its domain, and domain of cos x is 0 to pi, it becomes its range. If I draw its graph, we will get for -1 this is pi, for -1 the value of cos inverse x is pi, so -1, pi, this point is 1 and for 1 it is 0. If I join the curve, we will get a function like this. If I join these points, This point is pi by 2. For 0 it is pi by 2. Therefore, the range of cos inverse of x is 0 comma pi and domain is -1 to +1. If I put cos inverse 2, this is not defined because cos theta can never attain the value 2. Domain of cos inverse of x is -1 to +1 and range is 0 comma pi. Now move on to tan inverse of x. What is tan x? Y is equal to tan x. Tan x means sin x by cos x. Tan x means sin x by cos x. When cos theta is equal to 0, tan x will be undefined. That is cos x not equal to 0. That is x not equal to twice n plus 1 pi by 2. Add the odd multiples of pi by 2, cos x is 0. Therefore, x cannot be equal to twice n plus 1 pi by 2. Whenever cos x equal to odd multiple of pi by 2, tan x is undefined. If you draw the graph of tan x, you will get many branches. This is 0, this is pi by 2, this is minus pi by 2. The graph of tan x is like this. When x equal to pi by 2, tan x is infinity. For x equal to minus pi by 2, tan x is minus infinity. The graph of tan x is like this. If I draw another branch, this point is 3 pi by 2. This is pi. The graph will be like this. For x equal to 3 pi by 2, the value of y will be plus infinity. And for x equal to pi by 2 plus, the value will be minus infinity. The graph of tan x is like this. Now tan x is also a periodic function, that is not 1 1. We have to make it 1 1 by restricting its domain from minus pi by 2 to plus pi by 2. Now this function is a 1 1 function if I restrict the domain from minus pi by 2 to plus pi by 2, excluding those points. We have to exclude those points because for pi by 2 and minus pi by 2, tan x is undefined. Therefore, tan x such that open interval minus pi by 2 plus pi by 2 tends to real number. Why real number? The range of tan x is a real number because tan theta attains all the possible real values from minus infinity to plus infinity. The lines x equal to pi by 2, x equal to minus pi by 2 are called vertical asymptotes of sin tan x. What do you mean by asymptotes? Asymptotes are those lines which meet a curve at infinity. Now, if I find tan inverse of x, then we will switch the range and domain. Now, tan inverse of x has domain R and range minus pi by 2 to plus pi by 2. If I draw the graph of tan x, I will get this is 0, this is infinity. When x is equal to minus infinity, the value of tan x is equal to minus pi by 2. This point is minus pi by 2. This point is plus pi by 2. When x equal to minus infinity, the value of tan inverse of x will be equal to minus pi by 2. And for x equal to plus infinity, the value of tan x will be equal to plus pi by 2. The value is like this. This is your graph of tan inverse of x. Graph of tan inverse of x. When x tends to plus pi by 2, the value of y will be, when x tends to plus infinity, value of y will be plus pi by 2. For x equal minus infinity, the value of y will be minus pi by 2. Therefore, for tan inverse of x, domain is real number and range is minus pi by 2 comma plus pi by 2. Similarly, we can write what is cortex. Cortex is cos x by sin x. Therefore, sin of x not equal to 0. For sin 0, cortex is undefined. Hence, x not equal to n pi. For integral multiple of pi, cortex is undefined. If I draw the graph of cortex, we will get curve like this. For x equal to 0, it is plus infinity, and for x equal to pi by 2, it is 0, and for x equal to pi, it is minus infinity. The graph of cortex has more than one branches. If I draw another branch, I will get something like this. This point is 3 pi by 2. This is twice pi. The lines x equal to 0, x equal to pi, x equal to twice pi are the vertical asymptotes of cortex. If I restrict the domain of cortex from 0 to pi, we will get a 1-1 function. Because cortex is a periodic function, therefore, to make it 1-1 function, we must restrict its domain from 0 to pi. Now, cortex such that domain 0 comma pi, open interval. Why open interval? At 0 and pi, cortex is undefined. Therefore, you have to exclude those points. Tends to real number. The range of cortex is real number from minus infinite to plus infinite. Therefore, cortex is a 1-1 function in the domain 0 comma pi and range is real number. Now, a second function cot inverse of x can be described if we switch the range and domain of cortex. Now, R tends to 0 comma pi. This is a cot inverse of x function. The graph of cot inverse of x is, this is 0, this is pi, this is pi. When x tends to 0, when x tends to infinity, the value of cot inverse of x tends to 0, and for x tends to minus infinity, the value of cot inverse x will be is equal to pi. Therefore, the graph of cot inverse of x is something like this. This is something like this. The graph of cot inverse of x. It meets up to infinity and this is minus infinity. Therefore, for cot inverse of x, the domain is real number and the range is 0 comma pi. Why open interval? Because at 0 and pi, cortex is undefined. Therefore, we have to exclude those points 0 and pi. Now, for sec x, y is equal to sec x. What is sec x? 1 by cos x. 1 by cos x. What is sec x? It is 1 by cos x. If I draw the graph of cos x is this. Now, cos x is undefined at x equal to twice n plus 1 into pi by 2. Sec x is undefined at those points because cos x is 0. Therefore, these points are minus pi by 2 and plus pi by 2. This is 3 pi by 2 This is minus 3 pi by 2. Now, if I find the reciprocal of cos x, I will get a curve like this. It will go up to infinity, go up to infinity. Again here in this branch, I will get a curve like this. These are the branches of cos x. Now, branches of sec x. Now, sec x is also a periodic function. Therefore, to make it a 1-1 function, we have to restrict the domain from minus pi by 2 to plus pi by 2. From 0 to pi by 2 and pi by 2 to pi. Here the fx is 1-1 from 0 to pi by 2 and pi by 2 to pi. The graph of sec x is 1-1 and non-periodic. If I restrict the domain from 0 to pi, excluding the point pi by 2, the function cot x will be a 1-1 function. Therefore, you can write this sec x. Sec x is having domain 0, pi excluding the point pi by 2, because at pi by 2 sec x will be undefined. Therefore, we have to restrict the domain from 0 to pi excluding the point pi by 2. The range will be the value of sec x will start from 1 up to infinity and minus 1 to minus infinity. We can write minus infinity to minus 1 union plus 1 to infinity. We can write in this way, or all real number except the interval minus 1 to plus 1. Therefore, for sec x, the domain is this and the range is r minus the upper interval minus 1 to plus 1. If I define a function sec inverse of x, then we will switch the range and domain. It will be r minus 1 to plus 1 tends to 0, pi minus pi by 2. Therefore, for sec inverse of x, your domain is r minus 1 to plus 1 and the range will be 0, pi except pi by 2. This is your sec inverse of x function. Now, last function is cosec x. Y is equal to cosec x. What is cosec x? 1 by sin x. So, cos x is undefined when sin x is equal to 0. Therefore, sin of x is not equal to 0. That is, x not is equal to n pi. X not is equal to n pi. If I draw the graph of sin x, we will get something like this. Now, at 0, pi and minus pi, sin x is 0. Therefore, cos x will be undefined. If I find the reciprocal of the curve sin x, we will get a curve like this. This is minus 1, this is plus 1. Now, omit these graphs of sin x. This is the graph of cos x. Now, cos x is also a periodic function. To make it 1-1, we must restrict the domain of cos x from minus pi by 2 to plus pi by 2. Now, these branches of cos x are 1-1 except the point 0. At x equal to 0, cos x is undefined. Therefore, cosec x from minus pi by 2 to plus pi by 2 except 0 is a 1 function having range. Again, the range of cos x will be from 1 to infinity and minus 1 to minus infinity. That is, cos x has no value in between the interval minus 1 to plus 1. Therefore, range will be r minus 1 to plus 1. Hence, if I define a inverse function cosec inverse x, then we have to switch the range and domain. For cos inverse of x, your range will be r minus 1 to plus 1 tends to minus pi by 2 to plus pi by 2 except 0. Therefore, for cos inverse of x, range is minus 1 to plus 1 and this is minus pi by 2 to plus pi by 2 except 0. These are the domain and range of sin x, sin inverse of x, cos inverse of x, cot inverse of x, tan inverse of x, sec inverse of x and cosec inverse of x.